So, what is bit masking? Bit masking, I have this little test scene right here. Bit masking is a way for us to package a whole bunch of Boolean information into one number. And if you look right here, I've got a damage and a resistance, and I can enable and disable these different parts of the bit mask. But what is actually happening? So here's the test that I'm running, and you can see the damage and resistance, they're just integers. So how is it storing all of this Boolean information? Well, if you go all the way deep into computer science, everything in computers is 1 and a 0. So that number might look like this, like 100110. That would be, I don't know off the top of my head what that would be, but that's an integer number. And what we're basically saying is each 1 or 0 is just a Boolean for true or false, because that's also what the computer uses it for internally. Now, if we have the number, for instance, 1, 0, that's 2, that's 4, that's 8, this corresponds to the number 8. So if it's just 8, we know that the fourth bit is true. But if it's not, we have ways of knowing if it's off. So I've got down here, this isn't actually the one. Where did I put it? Scripts, health system, damage utilities. So I've made a class for myself that just contains a bunch of useful functions for this. And beneath the class, I have this enum, which assigns names to a bunch of integer values. So this right here is called the bit shift operator. You can apply it to integers. So I take the integer 1, which is actually represented as, well, it's down here already. It's represented as, let's say, 1, 2, 3, 4, 5, 6, 7, boom. That is the integer for 1. And what bit shifting is going to do is it's going to take these first 2 bits. So I'm bit shifting it. Let's say we're calculating the value for shock. So it's going to take these first 3 bits, get rid of them, and then input 3 empty bits there at the end. So I can insert them at the end. And so this is a different number now. This is 8. That's the binary value for 8. So I've got all of my basically named values for each binary number, and we're going to use that up here. So actually, if we go back and look at my property jar, you can see when they're all disabled, the number is 0. But if we enable, for instance, psychic damage, now it's 32. But if you want to do psychic and physical, that's 33. And so every combination of these Booleans, these bits, is going to be a unique number. So that's how we're able to package them so well. But then we need some sort of utility functions for working with them, because all we have is a number. We need to know whether that number is containing this enum flag or this enum flag. So I've got some of that. I have this function called contains type, which will return true if this integer contains this enum. Remember, this is the enum that's described. And we're doing this with what's called bitwise operators. So you might be aware of the double AND, which compares 2 Booleans. However, the bitwise, when you apply it to integers, is basically going to say, so this is our integer. Let's say it's 0010, and this will be this search target. So let's say we're searching for if fire damage is inside. So fire damage is bit shifted twice. I'm actually gonna compare this. So this is fire damage being compared to what the current damage is. So what the bitwise AND is going to do is it's actually going to give us a new integer, which is going to be if both this one and if both bits, this bit and this bit are 1, it'll return 1. Otherwise, if a single one of them is 0, it's going to return 0. So this will be 0, this will be 1, this will be 0, this will be 0. And so you can see why this is useful, because now we can basically check to see if this is the same as this, and if that's true, if this is the same as this, then we've basically confirmed that everything inside of this exists inside of this. All those bits are 1. So if we have, like, for instance, this is our damage, since this bit is 0, it's still going to return just this thing. But if this is 0, now it's not going to return the same second part of the operator. It's just going to return 0, and then this will be false. And then I have some overloads defined just so that I could do this for a whole array. Another thing you're going to need to do with bitwise operators is you're going to need to add them together. So you might want to combine 2 bit masks, and the way you do that is with what's called the bitwise OR. And so this is going to be the same thing as a Boolean OR, except it applies to each bit. So let's do our same example. Let's say 1 0 1 0 0, and let's say we are doing a bitwise OR comparison to fire, which is that. What we get is if either one of these bits is true, it'll give us true. So we know that one's false, this one's true, and then the rest are false. So what we're doing is we're just getting an integer, which is basically combining this and this together to make this. And so we could also go a little bit ahead. If instead of comparing that, if we compare something like this, if you combine these, you'll get that. So it is just adding them. And if they're already true, if there's 2 true, it just returns true again. And then I have again some more overloads for this. Another thing you'll need to do is possibly subtract bits from each other, and that uses the bitwise. There's no actual bitwise operator for that, but we do use a different type of operator. We use the bitwise invert. So what the bitwise invert does is it takes a bit integer and it just inverts it like that. And depending on how in what order and which one you invert, combining that with a bitwise AND will essentially do just a subtraction. So if this bit is true and this bit is also true, then it'll be like 0, this will be 0, this will be 0, but these two will be 1 because you're basically subtracting false from true. It's a little complicated, but it does work. So this is going to take this damage type enum out of this input integer. And then toggling does actually use a different one called XOR, but I don't actually use it. Instead, I made my own right here, which is essentially doing a subtraction, but you're flipping the input integer first. You're flipping the first one and then comparing it to the second one, and it does have some slight differences. But what this is essentially going to say is, let's say this is my resistance. Let's say this is resistance, and this is damage. Now this function is going to return true if this is anything greater than 0. So if this returns something that's not all zeros, it'll be true. So what we're going to do is we're going to actually flip this. So flipping that is going to be 0 1 1 0 1, and then we're going to compare that to 1 1 0 1 0. And what that's going to give us is now we're doing a bitwise AND. So that's 0, this is a 1, this is 0 0 and 0. So we see that this bit at the bottom is true, while this one at the top is false, doing a bitwise AND. So this does not equal 0, meaning our damage types have one of the damage type bits flagged that the resistance isn't resistant to. So this is kind of useful for things like maybe elemental type like Pokemon systems, where like if I'm doing a damage that you aren't resistant to, it can check that and basically say, oh, now it's super effective. And we can see that into play. So since these are my utility functions, I say, so first I have my resistance and my damage integers connected to their property jars. And then I basically say if damage utility dot compare resistance to damage. So if this is true, then we've taken damage. Otherwise, we negated the damage. So let's play around with this. Let's actually say fully resistant. So we're resistant to every single thing. If you try to attack me with, let's say, ethereal and holy damage, let's run this. It should say that I have negated the damage. The damage was negated. But let's see, maybe I'm not resistant to holy damage. Maybe that's my one weakness, is holy damage. Ah, I took damage. So that is very, very basic bit masking. It's not that it's not very elegant or easy to understand compared to just having a whole bunch of Booleans, but it's very useful for things like sending data around networks and whatnot. Thanks for watching the video.